My name's Kelly. I did a name degree. I actually did ecochemistry, but ended up working in drug design area for my honours, and so I'll talk to you a bit about my honours project. The title of my honours project was Optimisation of Triazole-based Inhibitors for Biotin Protein Ligase to Treat Staphylococcus aureus. But to make it a bit easier, what I actually was doing was making antibiotics to treat Golden Staph. So, this was my target protein. The green bit is the catalytic domain of my protein, and that's the area that I was targeting to make an antibiotic for this. The protein is called biotin protein ligase, and why do we want to inhibit biotin protein ligase? It's because if we find antibiotics for this protein, we can get a novel class of antibiotics, and that means that there's no pre-existing mechanisms of resistance in organisms that we try to target. So Golden Staph, you've got MRSA and bits and pieces, and so you want to have an antibiotic that's not going to be restricted by those sort of resistant microbes. The problem with BPL is it is present in all organisms. So you have to find a inhibitor that will be species selective. So why is targeting BPL going to stop the growth of Golden Staph? Well, it's important in this biological cycle, which ends up in membrane biogenesis, or basically maintaining the cell membrane. So if it can't maintain the cell membrane, the bacteria is going to die, and that's what we want. So we get rid of BPL, we inhibit that, we're going to stop this pathway from occurring, and we're going to get cell death. So in my project, I started working on a known inhibitor, which is this one down here, and I made modifications to it in order to see if we could find out more about the interactions with the protein, and also to see if we could optimize it in any way. So I made a few compounds. All of them had a similar basic structure, with the nitrogen group in this triazole ring on the other side, so on the biotin side, to see what effect that would have. So once I synthesized those ones, there's a couple of different analogues. I had to test them to see if they're effective. So we get the compound, we get BPL, or biotin protein ligase, the enzyme that we're trying to inhibit, and we put it in with the natural material which would be inside the cell, so it could perform its function that it normally performs inside the cell. And if our compound doesn't inhibit, it performs its natural function of attaching biotin to a biotin-dependent enzyme. And so you get the top one. But if our inhibitor works, then we shouldn't get it attaching. So we measure the amount of the biotin that's attached, and that gives us an indication of how well our compound is inhibiting BPL. So what did I find out? Well, my inhibitors with the reverse triazole ring showed decreased activity, which took in comparison to the ones that had already been synthesized with corresponding structure. And from that, I could determine that the triazole orientation and position within the enzyme was actually critical in dictating the potency of the inhibitors that were made. So, yeah, thanks very much for listening.